Morning, Brand class. What we are talking about today is multiplying mixed numbers. And a mixed number, to review, is a number that has two parts. It has a whole number part, in this case, the two wholes, and it has a fractional part. In this case, the fraction is 3/4. This is just a fraction. 1/2 is a fraction, but 2 3/4 is a mixed number because it's a mix of a whole number and a fractional part. So when multiplying a mixed number by a fraction or another number, there are two methods that you can use, and I'll show you both of those methods today. First, method one. When you're multiplying a mixed number, you have to multiply this factor by both parts of the mixed number. It is a mix, so it has a whole and a fractional part. It's just like a two-digit whole number. Let's say like 15. If we did 15 times 1/2, what we'd have to do is multiply the 5 ones by 1/2, and then we'd have to multiply the 110 by 1/2. We'd have to do two separate multiplications, and that's the same thing we have to do here. We have to multiply the 1/2 by the 3/4 and the 1/2 by the two wholes. One visual way to do this is to do an area model like you're familiar with. You say like 1/2 along this side, and then you split the 2 3/4 into the 2 part and the 3/4 part. And this area model just reminds you, oh, I've got to do two separate multiplications. First, I have to do the two wholes by 1/2, so 1/2 times 2 here, and then here I have to do the 1/2 times 3/4. Just reminding you, you need to multiply that factor by both parts of the mixed number. So 1/2 times 2. So that just means two copies of 1/2. It's the same thing as saying 1/2 plus another 1/2. 1/2 plus 1/2 is 2/2. Well, 2/2 is more easily written as one whole. So 1/2 times 2 is 1. And then 1/2 times 3/4. Now you've been practicing a lot with your multiplication. You know that when you have two fractions, you can just multiply the denominators to get the new denominator. 2 times 4 is 8. So now our denominator is eighths. And 1 times 3 is 3. So 3/8. Just like when you've done the area model in the past, you just take that partial product and that partial product, add them together, and that gives you your total product, 1 3/8. So in this case, the entire product is 1 3/8. So this is method one, where you just have to break that mixed number into two parts. Multiply the other factor by both parts of that mixed number. Method two can be a little more efficient, a little quicker, because you only have to do one multiplication instead of multiplying this factor by both parts of the mixed number. You only have to do one multiplication. How can you just do one multiplication? Well, that's by turning this number into a fraction. That's going to be a fraction that is greater than one whole, so some would call it an improper fraction. But it's basically you just turn it into a fraction. So when you have this number written as one fraction, then you can just multiply that fraction by this factor, this fraction here, and you'll get the total product in just one step. But I guess you have to do the extra step of turning this into a fraction. How do we do that? Well, let's look at this number. We've got 2 wholes and 3/4. So I'm going to draw out a picture of what 2 3/4 looks like. So that's one whole there. That's another whole. I have 2 wholes. So I'll shade in those 2 wholes, and then I'm going to have 3/4 of another whole. Since my denominator is 4, each of these wholes should be split into 4 parts because the denominator tells you how many parts make up one whole. And then for my shading, I'm going to shade in 2 wholes. So that's one whole shaded in. That's another whole shaded in, and then 3/4 of this other whole. So this picture shows two wholes, and this is the 3/4 part. That's how this is a picture of this factor 2 3/4. If I'm turning it into just a fraction, though, all I want is that I want the total number of fourths, so I can count those up. So all of these sections here is 1/4 because 4 of them make one whole. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections shaded in. So 2 3/4 is just the same as saying 11 fourths. I have 11 sections here. So now that I've changed this into a fraction, now I just have to do one multiplication. I again just multiply the numerators together to get the new numerator and the denominators together to get the new denominator. 4 times 2 is 8 eighths here, and 11 times 1 is 11. So with method 2, I get 11 eighths. Now 11 eighths with method 2, is that the same as with method 1? No, with method 1, I got 1 3/8. What's the difference here? 11 eighths and 1 3/8? Well, let's again make a picture of this fraction. Let's make a picture of 1 3/8. So that would be one whole, and I need another whole because I have one whole shaded in and 3/8 of another whole. My denominator here is 8, so I have to divide each whole into 8 pieces. Okay, and now if my number is 1 3/8, I have to shade in this whole here. So all 8 eighths are shaded in here because that's one whole. And then I have a 3/8 of another whole. So 1, 2, 3 of those 8 sections shaded in. So here's my one whole part, and here's my 3/8 part. Well, if I look at how many sections I have shaded in altogether, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hey, 11 eighths. 1 3/8 is the same as 11 eighths. So method 1 will often get you a mixed number as your product, and method 2 will often get you just a fraction as your product, but they will be equivalent if you do the method correctly. So there you go. With method 1, you just do 2 multiplications, multiply that factor by each part of the mixed number separately. And with method 2, you just turn the mixed number into a fraction and then just do that multiplication. You choose whichever one you wish. Now for a last bonus session, I want to show you what you need to do if you have 2 mixed numbers that you're trying to multiply together. So in this case, for method 1, remember in method 1 you had to split each mixed number into its whole part and its fractional part. So you're going to need to do that with each of the factors here. So that means if you do an area model, this area model is going to have 4 sections because you have to split up the 1 2/3 and you need to split up the 3 4/5. So just like before, I'm going to have to multiply the 3 by the 1 and multiply the 3 by the 2/3, and then I have to multiply the 4/5 by the 1 and the 4/5 by the 2/3. So now I have to do 4 multiplications when I have 2 mixed numbers, but I can do that. So in this quadrant here, it's going to be 1 times 3, and that is 3. In this quadrant here, it's going to be 1 times 4/5, and that's easy enough. 1 times 4/5 is 4/5. It's just one copy of 4/5. Here I am going to have 2/3 times 3. So that just means this is 3 wholes. So that just means 3 copies of 2/3. So if I count by 2/3 3 times, 2/3, 4/3, 6/3. So that's going to be 6/3. And I can already see that 6 is twice 3. So that's going to be 2 wholes. Nice. And lastly, I need to do the 2/3 times the 4/5. 2/3 times the 4/5. So in this case, I just have 2 fractions, so I can multiply their denominators together. 3 times 5 is 15 for my new denominator, and 2 times 4 is 8, so 8/15. Now I have 4 separate fractions I must add together, or 4 separate products, excuse me, only 2 of the products are fractions. So the 3 plus the 2 is 5. So these two together are 5. And now 4/5 plus 8/15. Well, already I see that I've got fifths and I got 15ths. I have 2 different denominators. That means I have different size pieces, so I cannot add these together. I have to change one of these fractions so that they have the same denominator as that one. So I'm going to make these fifths into 15ths. So 4/5 would be how many 15ths? Well, I know that 5 times 3 is 15. So if I multiply the numerator by the same amount here, by 3, then I'm going to get an equivalent fraction. 4 times 3 is 12. So 4/5 is 12/15. So now I can do 12/15 plus 8/15. 12/15 plus 8/15. And I've run out of room to put that sum now. 12 plus 8 is 20. So that's 20/15. Okay, so now I've got 5 wholes. I've got 20/15. I need to combine these two together. I'm going to do that up here. Well, 5 and 20/15. 5 and 20/15. Okay, that would be my product, but I notice one more thing is that 20/15, that is greater than 1 whole. So I know that 20/15 is actually just 1 whole plus 5 extra 15ths. So that 5 and 20/15, I'm going to turn that into 6 because I'm adding that 1 whole to the 5 wholes. So it's actually 6 and then 5/15 left over. So with method 1, there is a lot of math that you need to do to find equivalent fractions and then finally get to your final answer, which is a mixed number of 6 and 5/15. If we do method 2 with this same problem, method 2 just asks us to turn these both into fractions. I'm not going to draw the pictures for these because it's already a long video. So 1 2/3, that would be 1 whole. Each whole would be 3/3. So that's 3/3 plus 2/3, 5/3 there. And then 3 and 4/5. Each of these 3 wholes would be 5/5. So that's 5/5, 10/5, 15/5, plus another 4 would be 19/5. Then I just multiply them. 3 times 5 is 15. 5 times 19. I know 5 times 20 is 100. So 5 times 19, that would be 1 less 5 than 100. So 95/15. Whew, well, 95/15 and 6 and 5/15, they must be equivalent, right? Let's see. How many 15s fit in 95? So 15, I count by 15s, 15, 30, 45, 60, 75, 90. Yeah, I can't get all the way up to 95, but I can get to 90/15, which is 6 wholes. And then from 90 to 95 is 5 more 15s. So I get the same answer, just a little less work here with method 2.